4-5 congruence in right triangles. All right, example 1, when any two pairs of corresponding sides are congruent, can you show that two right triangles, triangle ABC and triangle DEF, are congruent? And explain. So we can prove this two different ways. The first way would be if we were given a side, we know we have this 90-degree angle, and then we were given another side. So side, angle, and then another side. We could use side, angle, side. But if we were given this side, if we were given these, now our side, angle, side, our angle isn't between the two sides, so we can't use side, angle, side, but we can prove this another way. So if we were given those two sides, but we have our right angle, we can use the Pythagorean theorem to find our missing side. So I would be able to find this missing side using Pythagorean theorem. So again, our Pythagorean theorem is a squared plus b squared equals c squared, where our c squared is the hypotenuse side, and then our other two are just the other two sides. Okay, so to find our BC, is equal to the square root of AB, which is our hypotenuse side. So then we would want to subtract our other side from it, AC squared, and that would be equal to our EF, which would be the square root of DE, which is our hypotenuse side, and from that we would subtract DF squared, which would get us EF. So if I did that, then I would be able to prove those two triangles congruent using side, 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 because we would be finding the missing side. All right, or try it. Can you show that two right triangles are congruent when any one pair of corresponding acute angles is congruent, and any one pair of corresponding legs is congruent? So first we're going to draw some triangles. And I'm going to duplicate this. Okay, so I've got my two triangles that I'm trying to prove. And they're telling us that any one pair of acute angles is congruent. So I've got acute angle, and any one pair of corresponding legs is congruent. All right, we're assuming that this is a 90-degree, and we have a corresponding leg here. Let me rotate. Oop, I don't want to do that. Rotate. I don't know if I can flip it. I'll just delete that. Okay. So I would be able to prove these two triangles are congruent through angle, side, angle. Or sorry, angle, angle, side. Okay, let's assume we're given another triangle. Set this up. I'm going to draw this one a little different. Oop. Okay, so we're just going to assume that those are the same, and we're going to label them that. All right, so this, again, our acute angle is congruent. So we'll say this acute angle. We've got our right angle. This would be our acute angle. We've got our right angle. And then the corresponding leg is congruent. Okay, so with this, I would be able to prove it through angle, side angle. All right, next, hypotenuse leg theorem. So if a hypotenuse and one leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So let's look at our example. Ashton is washing windows using a 10-foot ladder. For the first window, the ladder reaches the window when he places the base of the ladder at the rose bush. How can he determine where to place the ladder to be sure it reaches the last window? So if we have a triangle, I wonder if I can draw here and move it. Okay, we've got our triangle. Let me see if I can grab that and move it. Right like that. Nope, that works better. All right, so we've got our right triangle. I'm going to label this. They told us that his ladder is 10 foot. Okay, and this is a right angle, even though the triangle doesn't look that way. It's meeting up with the house. The house is creating a perpendicular with the ground, so that would be 90 degrees, even though the triangle doesn't look that way. All right, so in order to put the ladder at the same height on all of the windows, our X here would have to remain the same. So if this is A, B, C, my X would remain the same for all of my placements of the ladder. Or try it. What information is needed in order to apply the hypotenuse leg theorem? So we have our right angle. We are given one hypotenuse angle. We are not given the other. So we would have to know that this is 9, and then this would have to be 5. So we would need to know that the measure of MN, so side MN, was 5, and PR is 9. And that would allow us to use hypotenuse leg theorem to prove the two triangles. All right, so now we're going to write a proof using hypotenuse leg theorem. So we are given our perpendiculars and our sides that are congruent. We want to prove that ABC is isosceles. Okay, so we're trying to prove that the entire ABC triangle is isosceles. So we're going to start this out with our givens. Zoom in just a little more. All right, so we're given our perpendiculars. So FD is perpendicular to AB, and FE is perpendicular to AC, and that is given. Two, we know that angle FDA. Actually, let me give myself some more room here. So angle FDA is congruent to angle FDB, which would equal 90 degrees. Okay, so FDA is already listed as a right angle. FDB would also be a right angle. And then similarly, the right angle is on the opposite side. So angle FEC would be congruent and equal to angle FE, hold on, I messed up that last one. FEA is congruent to angle FEC, which would be 90 degrees. So that would be 90 degrees. And that would be through our definition of perpendiculars. Three, we are able to prove that triangle FEA and triangle FDA and triangle FEC, and then finally triangle FDB are all right triangles. And we are able to prove that through our definition of right triangles. Okay, number 4. Is another given, and we were given that AC is congruent to AD, and that is given. 5, we know that AF is congruent to AF through reflexive. Okay, so this is congruent. Next I can use hypotenuse leg to prove that FEA is congruent to FDA. Okay, and I did that because I had the hypotenuse leg. The hypotenuse leg was congruent to itself, and I had the adjoining leg for it. Okay, 7. I can prove that EF and DF are congruent. 1, 2, 3, 4. So I can prove that those two are congruent because I've proven that the two hypotenuse triangles are congruent. So EF was congruent to DF through corresponding parts of congruent triangles are congruent. We have another given, so we were given that FC is congruent to FB. I can prove my bottom triangles now using hypotenuse leg again. So I have my hypotenuse side that are congruent. I've got my right angles, and then I have another leg that is congruent to each other. So I can prove those triangles. So no FDB is congruent to triangle FEC, and that was through hypotenuse leg again. Okay, 10. I want to try to prove that my two base angles are congruent. So angle ECF would be congruent to angle DBF. And I can prove those because I've already proven their two triangles congruent. So I can use corresponding parts of congruent triangles are congruent to prove that those two angles are congruent. I want to prove that AC is congruent to AB. And I can do that through the converse of isosceles triangle. Okay, and then once I've proven that AC is congruent to AB, then finally I can prove that triangle ABC is isosceles. And I can prove that through definition of isosceles. All right, our next one, our try it. We are given our perpendicular bisector, or just perpendicular. They didn't tell us it's a bisector, so we're given our perpendicular JL and KM, and then we're told that JK is congruent to LK. And we need to prove that JKM is congruent to triangle LKM. So first thing we're going to do is our given one. So we are given JL perpendicular to KM, and JK is congruent to LK. Okay, because they told us that we have a perpendicular, this means this is at a 90-degree angle as well as this and this. So we know that angle JNK and angle LNK, angle LNK. Angle angle JNM and angle LNM are right angles. And that is through definition of perpendicular. Okay. Next, I can prove that Kn is congruent to Kn, Nm is congruent to Nm, and then Km is equal to Km through the reflexive property. All right, 4. Okay, J and K we know is congruent to L in K because they are both right angles. And that's because right angles are congruent. Right angles are always 90 degrees. They're always the same measure. Right, next, we can prove that triangle J and K is now congruent to triangle L and K. And we can do that through the hypotenuse leg because we have our right angle, our hypotenuse side, and then our leg, and we've got same thing over there, our hypotenuse side and our other side. So we can do this through hypotenuse leg. We can prove JKN, so we can prove, zoom in here a little bit, I can prove JKN is congruent to LKN through corresponding parts of congruent triangles. Then finally, I am able to prove my triangle JKM is congruent to triangle LKM. And I can prove that JKM is congruent to LKM. And I can do that because I have a side, an angle, and a side. So I have this side, this angle, and this side. Well, these two sides. Okay, so I can prove this through side, angle, side.